This is the 1-4 practice on the distributive property. And the first three problems are, again, just showing you how the distributive property works. They aren't super practical and useful, but then they help us to understand how it works so that we can start doing the mental math quicker, like in problems 4 through 6. So we have 9 times 7 plus 8, and the distributive property says that each thing inside the parentheses gets multiplied by the number outside. So we have 9 times 7 plus 9 times 8. 9 times 7 is 63, and 9 times 8 is 72. And then 72 and 63 are 135. 60 and 70 is 130, and then 3 and 2 is 5. We have 7 times 6 minus 7 times 4. We keep the symbol that's in between the numbers in the parentheses. So 7 times 6 minus 7 times 4. 7 times 6 is 42. 7 times 4 is 28. So our answer is 14. In number 3, we have the number on the back side. It doesn't matter. We can rewrite it, or we can just do it this way. So we have 4 times 11 plus 6 times 11. 4 times 11 is 44. 6 times 11 is 66. And that equals 110. 40 plus 60 is 100. 6 plus 4 is 10. So we have 110. And number 4 is where we start to get to see that the distributive property is useful for doing things in your head. So offhand, I don't know what 9 times 499 is. But if I could get 499 to look like something that I do know what 9 times that is, it would be easier. And when I'm doing the distributive property, it's a lot easier if I can get things to end in zeros. So if I could make 499 look like 500, then it'd be easier. So I'm going to rewrite 499 as 500 minus 1, because those are equal. I can put it in place. So I have 9 times 499, but my 499 is written as 500 minus 1. 9 times 500 minus 9 times 1. 9 times 500, 9 times 5 is 45. And then I have 2 zeros after that because I have 2 zeros in the 500. And then minus 9. 9 times 1 is 9. So I have 4,000. 500 minus 9 is 491. Again, in number 5, I'm looking to rewrite the number so that I have something that ends in a 0. Now, 7 times 110 ends in a 0, and you might know offhand that that would be 770, but if you don't, you can rewrite 110 to be 100 plus 10. And then we have 7 times 100 and 7 times 10. And hopefully we all know that 7 times 100 is 700. And that 7 times 10 is 70. So we end up with 770. And then the last one, we have a fraction, a mixed number. And if you did the section 1-4 skills practice video, you know that mixed numbers like this can be written as the sum of the whole number, the integer, 4, and the fraction, 1/4. And the reason that that becomes handy is now I can treat them separately. So 16 times 4, that's not too hard. I can do that. And then 16 times 1/4 I'll deal with in a minute. 16 times 4, well, 16 and 16 is 32. So 2 16s is 32, which means 4 16s is 64. And then 16 times a fourth. Well, whenever you see a fraction and the denominator is 1, and it's being multiplied by a number, what that really means is that you are dividing by that number on the bottom, the denominator. So 16 times a fourth is the same thing as 16 divided by 4. And I can replace them because they're equivalent expressions. They mean the same thing. They equal the same thing. And I know what 16 divided by 4 is. That's 4. So I got rid of the big bad fraction. And I don't have to deal with it anymore. In numbers 7 through 12, we're going to be using the distributive property on expressions. So again, we have the number on the back side. It doesn't matter. If you wanted to write it in the front side, you could certainly reorder it and do it just the way that we've been doing things. But I'll give you some practice in doing it this way as well. So we have 9 times 3 minus p times 3. 9 times 3 is 27. And when we write numbers times variables, we put the number in front and no multiplication symbol and then the variable. When they're right next to each other, it means multiply. And when they ask us to simplify an expression, it means there's no like terms, and a like term means that they have the same variable and the same exponent on the variable, and that there's no more parentheses. So this is true of what we just wrote, 27 minus 3p, so we're done. 7 gets multiplied by both, so I have 5y times 7 minus 3 times 7. When I have numbers being multiplied with variables, the numbers get multiplied all together. So 5 times 7 is 35y, and then 3 times 7 is 21. There's no more like terms and there's no more parentheses, so I'm done. In number 9, I have 15 times f and 15 times a third. Fifteen times f just turns out to be 15f. You take out the multiplication sign. That's all you do to make it final. And 15 times a third. What we just talked about in number 6 is that if we have a numerator that's 1, and then we're multiplying that fraction by a number, what that means is that you are dividing by that denominator. So 15 times 1/3 is equal to 15 divided by 3. Well, now that I've gotten rid of the fraction, I know what 15 times 3 is. That's just 5. Or excuse me, 15 divided by 3 is, that's just 5. And then I'm done. In number 10, 16 gets multiplied through, and I have a decimal, which we'll deal with in a minute here. So I have 16 times 3b minus 16 times 0.25. Well, 3 times 16, 16 plus 16 is 32, plus 16 is 48b, minus 0.02 or 0.25 is just the fraction 1/4. So I can rewrite that using the substitution property as 1/4. Now the reason I wanted to do that is because we just talked about in problem number 9 that if I have a 1 on top of the fraction, then I'm dividing by the denominator when I multiply it. So I can rewrite 16 times 1/4 or 16 times 0.25 as 16 divided by 4. 16 divided by 4 is just 4. In 11, even though we have a letter, a variable out front, we treat it like it's a number because it is. It's just any number. We don't know its value. So m gets multiplied by m, n. So m times n, and plus m times 4. So when I multiply two variables, I stick them right next to each other, just with numbers. No multiplication symbol in between. And then when I multiply a number and a variable, the number always comes first. Now, while both these terms have an m, they don't both have an n, so they aren't like terms. They have to have all the same letters with all the same exponents on those letters. And the last one, number 12 for this page here. D gets multiplied by both. So I have C times D minus 4 times D. So like I said before, if I have two variables being multiplied, I just put them right next to each other, CD, and then the 4 goes right next to the D. And again, this one has a C, this one doesn't. So these are not like terms, they cannot be combined. In numbers 13 through 18, we're going to try and simplify it. And what we do a lot of times when we simplify it is we do the distributive property backwards. So in number 13, I have a common factor of W in all of those things. And what happens with that is if I do the distributive property backwards, I can pull that W out and put the rest of the stuff in parentheses. Now in this first one where it just says W, remember that there's an implied 1 there. There's one W. So when I take the W out, I have 1 plus 14 minus 6. Now I want to show you how you can check your work to see if you've done it right. So what this looks like is if I multiply W through doing the distributive property forwards, I have W times 1 plus W times 14 plus, minus W times 6. Well, when I rewrite that all, I'd just have W. I'd leave the 1 off, plus 14W minus 6W. So you can see that we haven't changed it at all here. We've just rewritten it in a way that's going to be more convenient for us. So coming back to the problem at hand of simplifying this, we have to get rid of all of the common factors, which are the ones that have W's. So in here now, I can add 1 plus 14 is 15, minus 6 is 9. So I have W times 9, which then I would write as 9W. In the next one, I'm going to do the distributive property through and see if there's any like terms that I need to combine. So I have 3 times 5 plus 3 times 6h. 3 times 5 is 15, plus 3 times 6 is 18. And since this doesn't have an h and this does, they are not like terms, so I don't combine them. And I'm left with just 15 plus 18h. In the next problem we have b squared, 12b squared, and 9b squared. They have the same variable with the same exponent, so we can pull the b squared out, and then we're left with 12 plus 9. 12 plus 9 is 21. And then to finish it, we just put the number in front of the variable. 16, we have t cubed and t cubed, so those are common factors. We pull them out front, and we are left with 25 minus 17. 25 minus 17 is 8. And then we're left with t cubed times 8. We put the number out front, and we're left with 8t cubed. In number 17, we have a squared, a, and b squared. A squared and a both have the same variable, but a squared does not match a in the exponent. So there are no like terms here, so this one is already simplified. In number 18, we're going to go through and do the distributive property forwards. So the 4 gets multiplied by everything inside the parentheses. So 4 times 6p minus 4 times 2q, plus 4 times 2q, minus 4 times 2p. 4 times 6 is 24p. Plus 4 times 2 is 8q, minus 4 times 2 is 8p. Well, 24p and 8p match, so I can pull the p out front, and then I have 24 minus 8, and then the plus 8q stays on the outside because it doesn't match. 24 minus 8 is 16. So I have p times 16 plus 8q. And then the finishing touch is to write the number before the variable. In numbers 19 and 20, we go back to section 1-1, which was writing expressions for verbal expressions. So 4 times the difference. So if I was to write what the difference of f squared and g is, difference means minus. So f squared minus g, and I want 4 times that. So I put parentheses around it and put a 4 out front. Increased by means I'm going to add. The sum means in between my f squared and 2g I have a plus. And then it says simplify and indicate the properties used. So the first thing I'm going to do is to use the distributive property to get rid of those parentheses. So 4 times f squared minus 4 times g plus f squared plus 2g. I haven't done anything with those, so they stay the same. And that's the distributive property. So I have f squared and f squared here. Remember, if there's not a number in front, there's an implied 1. So 4f squared plus 1 f squared. And then I have minus 4g and plus 2g. And I'm just going to reorder them because I get confused sometimes. So I'm going to put a plus in between, and then I'm going to put my minus after. So I'm going to have the g out front, and then 2 minus 4. And I'm just doing that so that I keep my signs straight. It's easier to have the negative after something, so it looks like a minus sign. And that is simply the distributive property backwards. 4 plus 1 is 5, so I have f squared times 5. And then 2 minus 4 is negative 2, so I have g times negative 2. And that's the substitution property. Subs. And then I would write the numbers in front. So 5f squared, and then plus negative 2g. And when I write plus a negative, what that really means is subtraction, so I can write that as 5f squared minus 2g. And that would also be a substitution. All right, 3 times the sum of x and y squared. So the sum of x and y squared looks like x plus y squared. And then it wants 3 times that. So I put parentheses around it and multiply. Plus 5 times the difference of 2x and y. 2x and y, the difference of that means a minus sign in between. And then 5 times that means a 5 outside the parentheses. So I'm going to go through and use the distributive property. Whoops. Just kidding. Got a little line happy there. So I have 3 times x plus 3 times y squared plus 5 times 2x minus 5 times y. And that's the distributive property. So I have 3x plus 3y plus 10x minus 5y. That's substitution, just putting in that 5 times 2 is 10, basically. Well, then I have 3x plus 10x. Those have a common factor of x, so if I pull it out, I have 3 plus 10 in the parentheses. And then I have 3y minus 5y. So if I pull the y out, that's the common factor, I have 3 minus 5. And that's the distributive property backwards. 3 plus 10 is 13. And 3 minus 5 is negative 2. Put the numbers out front. So this is just the substitution property. Now I'm going to put the numbers out front. And remember that when I add a negative, it's the same thing as subtracting. And that would be the substitution property. All right. The last problem, word problem. The Ross family recently dined at an Italian restaurant. Each of the 4 family members ordered a pasta dish that cost $11.50, a drink that cost $1.50, and a dessert that cost $2.75. So there's 4 of those meals that have $11.50 and $1.50 and $2.75. Well, there's 4 meals that look exactly like that. So if we were to write an expression, I would say, well, here's how much one meal costs. Here's when I multiply it by 4, that's how much they're all going to cost. So what was the cost of dining out for the Ross family? Well, I'm going to do some adding in the parentheses before the multiplication. So $11.50 and $1.50. Well, if I bring the 50 cents over together, then $11.50 and 50 cents is 12 plus 1. And then 12 plus 1 is 13. $13 plus $2.75 makes $15.75. And then $15.75, since I'm trying to do this in my head, I'm going to replace with 15 plus 0.75. And then I'll use the distributive property. And I have 4 times 15 plus 4 times 0.75. 4 times 15 is 60. And then I'm going to rewrite 0.75 is the fraction 3/4. And when I have fractions being multiplied and the same number is diagonal, like those two 4s, they cancel out. So I'm left with 3. 60 plus 3 is 63. I look back up, we're talking about cost, so my units are dollars.